Hello students, let's have a look at some of the figures here. They have their individual names obviously, but as a whole, when we join number of points without lifting a pencil or without retracing the lines on the paper, we call them curves. Now these curves, they have area enclosed within them. This blue portion is the area enclosed by them. So curves which has no starting point and it has no end point, we call them closed curve, and they basically will enclose some area within them. So these types of curves are called closed curve, and in closed curve we have simple closed curve, that is a connected curve that does not cross itself and ends at the same point where it begins. For example, we have this rectangle, this circle, a triangle, a pentagon, and a hexagon. They all have ended at the same point and the lines are not intersecting or crossing themselves. So we call them simple closed curve. Now we see this curve. This is also a curve. This is also a curve. This also is a curve. And this is also a curve. We call them open curve. They don't enclose any kind of area within them. They are open. They have a starting point and they have a ending point. So here we have the definition for open curves. Let us have a look at these figures. They have many sides. There are 3 sides, 4 sides and 5 sides. We call them generally polygons. So when we draw curves only using lines, then we call them polygons. And poly means many, gon means side. So polygons, many sides figure. Let us try to understand polygons on the basis of their interior angles. We have convex polygon. In a convex polygon, each angle measures less than 180 degrees and their diagonals will always be in the interior part of the polygon. The second type is concave polygon. Here, each interior angle may be more than 180 degrees and the diagonals may be outside or in the exterior part of the polygon. So a convex polygon and a concave polygon. There is yet another type of polygon on the basis of their measurement of the sides and measurement of each angles. The first type is a regular polygon. Now what are regular polygons? They are basically having equal lengths and having equal interior angles. For example, here we have a square where all the sides are equal and each angle is 90 degrees each. We have the second figure, a triangle, which is also called an equilateral triangle, where all the sides are equal and each angle is 60 degrees each. And we have a regular pentagon, where all sides are equal and each angle they are equal to one another. The second type is obviously the irregular polygon. Now they will not have equal length and they will not have equal angles. For example, we have a rectangle where the opposite sides are equal but all sides are not equal to each other. We have an isosceles triangle where 2 sides are equal but it's not equal to third side. We have a pentagon or irregular pentagon. None of the sides are equal here. So these are the types of polygon on the basis of their sides and their angles. Let us look at this figure having 3 sides and they are equal to one another. we call this triangle equilateral triangle. We have again these three sides having two sides equal. We call it isosceles triangle. Again, we have this triangle having three sides equal and one of the angle measuring 90 degree. Then we call this right angled triangle. Again, we have this figure having three sides which are unequal. We call such triangle as scalene triangle. Now, they have their individual names, but together we call them triangles because they are having three sides, they are having three angles, so triangle. Now, we have this figure having four sides, and all the four sides are equal here. Each angle is measuring 90 degree. We call it a square. Again, we have four sides and opposite sides are equal. Each angle is 90 degree. We call such figure as a rectangle. So they have their individual names. They also have four sides. There are other figures also having four sides. So we call them generally figures having four sides are known as quadrilaterals. Quad means four, laterals means side. So they have four sides, so we call them quadrilaterals. At the end of the lessons, you'll be able to define and identify simple closed curves, define polygons, identify convex, concave polygon, regular and irregular polygon. You'll be able to calculate the interior angles and exterior angles of given polygons. You will also be able to identify different types of quadrilaterals, and you will be able to identify the properties of special quadrilaterals, or we call them parallelogram, for example square, rectangle, rhombus, etc. And finally, you'll be able to solve questions related to the special parallelograms. Let us try to understand the angle sum property of different polygons. We'll start off by taking a polygon having only three sides, because there are no other polygons having two sides. So equilateral triangle, they have all sides equal, and each angle measures 60 degree, meaning angle A plus angle B plus angle C is equals to 60 degree plus 60 degree plus 60 degree. So total angle is equals to 180 degree. We can see that angle sum property of a triangle is 180 degree. Let us take a quadrilateral PQRS. When we join P and R, we get two triangles, PRS and PQR. As we know that each angle for these triangles is 180 degree. So when we join the angles of these two triangles, that is 180 degree plus 180 degree, we get 360 degree, which is nothing but the interior angle of this polygon PQRS, that is a quadrilateral. Now, if we start doing this with every type of polygon, then it will be very meticulous work. So, to make it easier, it will be easier for us if we have a formula. So, the formula here is number of sides minus 2 into 180 degree, which can also be written as sum of interior angle of a polygon equals to n minus 2 into 180 degree, where n is nothing but the number of sides. So the examples that we have done here earlier, PQRS, instead of drawing P and R and taking triangles, different triangles, and then adding the total angles, we can do this as we have number of side 4, that is PQ, QR, RS and PS. So sum of interior angle of a polygon equals to n minus 2 into 180 degree. That is the formula, n minus 2 into 180 degree. And in place of n, we can put the value 4. So it becomes 4 minus 2 into 180 degree. And we know that 4 minus 2 is how much? 2. And 2 times 180 degree. When we multiply 180 into 2, we get 360 degree. So if you have been given any number of sides for any polygon, then we can easily find out the total angle for its interior portion. Let's try to solve this question using the formula. Find the sum of interior angles of a polygon having 8 sides. So we have the number of sides as 8, and the formula is sum of interior angle of a polygon equals to n minus 2 into 180 degree. Remember this formula, n minus 2 into 180 degree. So sum of interior angles of a polygon having 8 sides, which is also called octagon, is equals to 8 minus 2 into 180 degree, because number of sides is 8. So 8 minus 2 is 6 into 180 degree, and when we multiply 6 and 180, we get 1080 degree. So the total angle of octagon is 1080 degree. So if you have been given only sides for any polygon, then you can easily find out their total interior angles. Now let us have a look at this example. Find the angle measuring x in the following figure. We have this figure of a quadrilateral. It has 4 sides, a quadrilateral, where one angle is 50 degree, the other is 130 degree, the other is 120 degree, and here we have x. This is the one that we are supposed to find out. Now since I said it is a quadrilateral, so let us first find out the total angle of a quadrilateral. So we have 4 minus 2 into 180 degree after using the formula, so equals to 2 into 180 degree, that is 360 degree. Meaning if we add all of these angles, 50 degree plus 130 plus 120 degree plus x, we get 360 degree. 50 plus 130 is 180, so we get 180 plus 120 plus x is equals to 360 degree, and 180 plus 120 is equals to 300 degree, so we get 300 degree plus x equals to 360 degree. We know that we need to take 300 to the right hand side, leaving x on the left hand side, so 360 minus 300, so the value for x is 60 degree. So we got the value for x as 60 degree. So let us take another example which is quite different from the first one. Here we have a triangle where the sides are extended, and we have this measurement of interior angles as 30 degree, 90 degree, and one of the angle is A, meaning we don't know the value of that angle. And we have this x, y, and z beside 30, 90, and E. Now before we solve this, let's try to understand the question. The question says find the value of x plus y plus z. So it's very important for us to understand what we are asked to find. So reading the question thoroughly is very important. Now before we do this question again, let's try to understand this portion here. If you just take this portion, we have a line which is horizontal, and we have an arm on the line standing on the line. We have this z, we call this the exterior angle. We have this 30 degree which is inside, so we call it interior angle. Now if we add this, we know that z plus 30, because this is a straight line, and we very well know that straight line is equals to 180 degree. So we can write z plus 30 degree as 180 degree. So whenever we get this kind of scenario or this kind of figures, we can always write these two angles to be 180 degree, and whenever we can write these angles 180 degree, we call them as linear pair of angles. So you need to keep this in mind, linear pair of angles. Now we'll come back to the question here. Find x plus y plus z. So we have to find out the value for x, y and z. Before we find out the value of x, y and z, we need to find out the value of a, because without finding the value of a, we cannot find out the value of y. So angle sum property of a triangle we very well know is 180 degree, meaning 30 degree plus 90 degree plus a is equals to 180 degree, and 30 plus 90 is 120, plus a equals to 180 degree, and a equals to 180 minus 120, so a equals to 60 degree. So we found out a equals to 60 degree. Now we have all the interior angles known to us. So we'll start finding out serially from x, y and z. So when we add x and 90, we know that it is on a line, so we can write them as x plus 90 as 180 degree. So we need to take 90 degree towards the right hand side. When we take them, it is becoming negative, so x equals to 180 minus 90 degree, and x equals to 180 minus 90 is 90 degree. So we got the value of x as 90 degree. Now let us find out the value of y. Y plus y plus a is equals to 180 degree. So in place of a, we can write 60 degree, because we have found out the value of a as 60 degree. So we can write this as y plus 60 degree equals to 180 degree. Now we need to take 60 towards the right hand side. So y is equals to 180 minus 60, and 180 minus 60 is 120. So y is equals to 120 degree. Now we are left with z. So z plus 30 degree equals to 180 degree. We take 30 towards the right hand side. So z equals to 180 minus 30, and z equals to 150, because 180 minus 30 is 150 degree. Our question was to find out the value of x plus y plus z. So x is equals to 90 degree, y equals to 120 degree, and z equals to 150 degree. So we get 90 plus 120 as 210. So our new equation is x plus y plus z equals to 210 plus 150, and 210 plus 150 is 360 degree, meaning x plus y plus z is equals to 360 degree. As we know that all of these angles x, y and z, they are the exterior angles, so sum of exterior angle is equals to 360 degree, and it is true for any polygon. So if you have a quadrilateral also, sum of exterior angle of a quadrilateral will be always 360 degree. So we can conclude as sum of exterior angle of a polygon, that is any polygon, is 360 degree. This ends the first part of the quadrilateral. I'll be uploading the second part very soon to make you understand more about quadrilaterals, special quadrilaterals like that is parallelogram and all. So please wait for the video and watch this video very carefully so that you can understand the whole concept of quadrilaterals. Thank you.